Hi, I am Shane Brinkman-Davis, and in association with Jen UI and Amy Kimmy, this is going to be a live coding episode. Today I want to revamp my how to build a Turing Complete programming language in 40 minutes. I did this video years ago on YouTube. When was it released? 2012, September, so that's pretty close. That is, 7 years ago. And it was on Ruby, and it was pretty cool. It got relatively well received for what it was, 14,000 views. But I was building that upon a tool that was at Turing time called PaperBridge, and now I have ported it and updated it and improved it onto the Node platform in JavaScript, and it is now called CaffeineEight. And so this is a live coding. So I'm just going to be fumbling through getting this set up, and then I will do a separate video where I actually do it where it looks all smooth and looks like I know everything that I'm doing. So this is what goes on behind the scenes. This is what's going on inside the kitchen. Let's see how this is going to work. So I'm just going to put this as an example inside the CaffeineEight project. And I'm going to take this JSON parser I've already built. I don't even have to say CaffeineScript anymore. That's now default. And I'm going to just run it. It's not really Turing. It's actually this JSON parser. But if I said true, it says it doesn't like it because that's not legal JSON, but if I said true in brackets, it says it likes it. If I say foo is true, it likes it. So that's all nice. That's what the JSON parser is going to do. But now what I want to do is I'm going to come over here. I'm going to use this as a reference. This is my original source from the original demo. And we're going to say Turing parser, and I didn't even rewatch the video, which probably would have been helpful for me to have a frame of reference on what I'm doing. So I believe in here the root rule was just your first rule. Now you have to actually have a rule called your root rule. So the root rule is statements, and a statements is statements, one or more statement, and a statement is, well, right now let's just make it something stupid, like 1 + 1 is the only legal statement. Now we're going to run that. Every step of the way I'm going to be just kind of trying stuff out. So that, not legal, 1 + 2, not legal, 1 + 1, it likes it. So that's nice to see that that works. Now, a statement, we've got a lot of different things. I wonder how I built it up originally. But fundamentally, a statement is an if statement, an if then else statement here, or a binary operators, and I've got brackets, and I've got parentheses. So let's start with the binary operators rule. Oh yeah, I've got this thing which does priority built into this version. I'll have to look how I do that now in the newer stuff. I might just do a prefix operator. My old solution actually had a little built-in thing that would help you parse binary operators with precedence, which is pretty slick, but I decided not to have quite as much built in to CaffeineEight as opposed to the old PaperBridge, so I don't think that's built in anymore. I might go and reference how CaffeineScript does it, which you'll notice the programming language I'm using. What is this programming language I'm using? .caff. It's CaffeineScript. CaffeineScript is my language. It lets you write JavaScript in 3 to 5x less code. It's based on CoffeeScript. It starts where CoffeeScript left off and goes much further down the line of block-oriented programming, which is say indentation defines blocks, and a lot of other little things to streamline code, make better code, let you write better JavaScript code in less code. And I think it really increases my productivity. And so I've got this whole thing, CaffeineScript, which is written using this tool called CaffeineEight, and therefore it has operator precedence. And I might go look at how I did it in there, but I don't think it's built in. I don't think we get it for free, and so I think I might just gloss over it and we'll do prefix versus index, at least for this first version. So this is a root statement could be an operand. sure. I'm just going to call it an expression here, and it's going to be an operator and a value and a value and a comma and a value. It's going to be separated by a space. We're going to just go and pull this out. And this is an optional space and an optional space. All right, so operator can be one of, just going to do a regular expression, which is one of the legal things we can do. It's going to be one of all these operators. Or we're just going to do it like this. We're going to have to escape a couple of these things, of course. We actually don't want those. So we got times, plus, minus, less than or equal to, greater than equal to, and we should do a divide. Some of these are non-sequences, so I'm just going to do them all here. Divide, minus, plus, times, divide, and that gets us to here. And then we can also do less than and greater than in this set. But then these other ones are pairs, and so we can't quite do it that way. But that should detect operators. And a value right now is just going to be, let's just do a digit. What do I do down here? I got operand is optionally negative also. I can actually do this whole thing just as is. Perfectly good. Now let's go and see what it thinks about this. Oh, I don't think I have it. Invalid regular expression for one. Because I have a parentheses, which I don't need, that's fine. And we want it to be an expression now. 1 plus 1. Parsing error, and not a very nice parsing error at that. I need to prove how that works. That's kind of unfortunate. Well, that's what we're here to do. All right, let's go back over here. And this new pattern, use build.js, module that exports equals false. And then I'm going to come over here, and this is going to say require use build in the current directory. I think that's actually all it is. But then and now we can actually go over here and find the REPL source. We're going to fix this problem. So the REPL here tries to execute it, it catches the E, calls back the E, is this also retified? So I'm just a little bit confused about where it's going here and why it's not coming through nicely. So here 1, here 2. When in doubt, put in a couple of statements there to see what's going on. Here 1, this is not surprising to me. Now I want to know why you're not coming through nicely. 1 plus 1, that's what I should be saying. Why am I not seeing it? Instead, it's just failing. I like that well enough right now. We're going to keep moving forward. All right, 1 + 1, expecting statement to continue root. Let's go see why is that doing what it's doing. So we are going to go back to where we were, which is in the examples and the Turing one. So it should be statement is multiple statements, which is an expression, which should just be one expression, which is actually expression could be two things. Actually, it could be a value or an operator. Oh, because it's not infix anymore. +1, 1. And we need to change this a little bit. I think, do we need to have commas? Probably. In fact, we might. Doesn't really matter right now, so we'll just keep moving. +1, 1. It likes it, finally. All right. It also should like just a single value. -10, 10, but we're not allowing fractions right now. That's okay with me. Now, we're going to want to allow a value can also be a parenthesis followed by optional space followed by an expression followed by optional space followed by a closed parenthesis. So that's where we're going to introduce our parentheses, which means I could do +1, 2. It should accept that, but it doesn't. 1 doesn't like that either. That's right. Because it's an object, two values are the same. It's just going to, actually right now it's redundant. It just ignores the first one. 1 +1, 2. Does it actually require space there? It does. It doesn't need to require space. That can be an optional space here. This should require it can be an optional space right now. So it could be a fetch, which a fetch is going to look like this. It's going to look like almost the same, except for it's going to be like that. And we're just going to say that this is a value inside here. I'll say the same, say it's an expression. And it could be a set. We want to match a set first. Store get, store set. We're going to call these instead. Store set and store get. And conveniently, store set is a store get followed by an optional space and equals an optional space and an expression. Let's try that out. That way it didn't, we want store set to be matched first because otherwise it's going to be overly greedy, because that's the way how parsing expression grammars work. 1 = 3, or just like that. Great, it matches all those things. Store set, store get, values, parentheses, operators. Now we need looping and testing. So we're going to write our little test. What the syntax? I said if statement, then statements, else clause, question mark, and sure. Sounds good. So a statement is going to be, we're going to change this a little bit. It's an expression followed by optional space, followed by a new line. Let's escape that twice. In fact, I like calling it something like end line, so I can just write it nicely like that. It is a space star, any number of spaces, followed by a new line, followed by any number of new line spaces, like that. And then we can just say end all. I'll put this down here at the bottom. And I have to even put that there because that's now built in. Statement is an expression with an end line. And the end line, I'm going to put a special little thing here. So it could be a new line, or, in fact, I'm going to make this a little nicer because I really don't like doing that. Escape the space, and then it can be followed by a new line or a end of buffer, followed by that. Great. So that's cool. Proceeding along. Only have 30 more minutes or so here today. Let's see how this goes. So we're cranking on this. Let's see if that parses actually. Good places to go. One doesn't think, I thought you might not like that. It should be able to match it though. Any number of spaces followed by, oh, it's endl versus endline. I'll try to use endl because that's nicer actually. Actually, I'm kind of surprised it didn't complain about that. 1 plus 2. 1 plus 2, 3 plus 4. Expecting all this thing to continue expression. Shouldn't that have fully matched an expression? Statements is one or more statements. And we'll come back around to that after a minute. Let's finish looking at these other things that need to happen here. We got store get, store set, and we are working on building out if. Which I'm just going to make this another kind of expression. If expression looks like this. If keyword followed by a space, followed by an expression, followed by an option by space, followed by then, followed by an expression, and then an optional else clause, followed by, so do a space there, and then we're going to have a end. And else clause looks like this. Else right off the bat, space, expression. One of the patterns I've ended up liking when you're dealing with spaces explicitly in parsing is you always deal with them as an infix between other things. You don't deal with them at the beginning or ending of a pattern, and you instead, when you're using it in the other pattern, then you put in around it. So if it's always as an infix, then you always know where to put it. You don't end up matching it twice, which can be problematic. All right, let's go see how this matches. This is an if expression, so this is one of the things that an expression can be. In fact, we're just going to do it like this, because it doesn't need to be fancier than that. I'm going to call this an operator expression. So we can do it like this as well. Let's see how that works. Doesn't have history. Well, this one, 1 plus 1, doesn't like me anymore. Oh, 1 plus 1 doesn't match the end. That's what's going on here. If I do 1, doesn't like that either. Is it just because of this endline thing? Let's just try it real quick. Okay, so I keep forgetting that I'm doing infix. But that did seem to be a problem for that. I'm not doing infix, I'm doing prefix. But this one stops matching when I add that in. I'm not quite sure why. Because expression can be a value can be parenthesis, expression, close parenthesis, and then followed by any number of spaces, and then an end of buffer. I'm looking for a B, I'm looking for a break. It's not what I want. I want $sign. There we go. Sweet. Now let's do if 1, then 2, else 3. Right. If 1, then 2. Right, so here's the thing, right? We've got an expression. We don't want to match this twice. We have the problem, it's looking for 2 spaces and it's not going to get them if there's no else clause. So in this case, I'm going to break my little rule, and we're going to say it's like this. So it doesn't match it twice. If 1, then 2, end. If 1, then 2, else 3, end. Beautiful. All right, so now we have if and else clauses matching. This, I'm going to say an expression, all these things. I'm going to say a statement can have optional space at the beginning. That way we can, it's going to be more forgiving. So I can do something like 1, and it's happy with that. And then I also want to say, so these are statements. So I want to actually say this is not, these are statements, which just allows us to do more than one thing in a statement set. We'll just do my CaffeineScript interpretation of what statements is in an expression. It's the last statement in the statement set. It's the value that gets returned for the expression. So only that's special about statements is that you can have a set of them, and it'll execute them in order. Everyone except for the last one, their return results ignored, the last one's returned. But that allows us to write, I think, what looks more like a normal if statement. So we say if, I'm going to do the editor, if 1, then 2, 3, end. If 1, then 2, end. That really doesn't like me. Statements, statements have to have an end line. What if I just made this an optional end line? If 1, then 2, end. Dot editor. If 1, then 2, then 2, end. Yes, thinking that might happen because I think I actually need to make this an end line start. Which remember, end lines allow spaces and end lines and so forth. So we can have some new lines before it too. That's also perfectly fine. Again, making it a little bit more forgiving. Editor, if one, then two, end. So close, so close. So end here, I'm going to make this an end line. And it is expecting it, but I want it to be an end line or a space. Which I'm going to do like this. End line is space or an end line. Now let's try this one more time. Editor, if one, then two, three, end. Still doesn't like me. Then, I think then has the same problem, right? Well, the statements, oh, it's expecting a real space there, right? In fact, given that this whole language I might be able to just get away with making we'll keep moving as is right now. I might be able to get away with getting rid of those entirely. If one, then two, end. Yeah, I thought that was going to do it to me. Because statements is just going to consume that end line right there. So it's we're never going to have an end line at the end of statements. Because statements always ends in an end line if it's present. And else probably should have an end line here, an underscore end line. I think we can just do statements, right? Because statements is going to it'll suck it up. If one, then two, end. Still doesn't like me. Statements is expecting a possible thing in front and a possible expression. One plus one, two. All right, so it's looking for statements. Statements is multiple statements. So let's just, simplify until it works. Expression. We just have an expression here, but we need to have these if we have expression. That goes there, that goes there. If one, then two, end. Still doesn't like it. It says expecting if expression. So it's expecting an expression right there and it's not getting it. Okay, so that makes some sense. I don't know why it's doing that, but it's expecting an expression here. I want to underscore end line. That's what we're doing here. Those should be underscore end lines. If one, then two, end. Now you really don't like me. So if we just say underscore and underscore, then I think it'll one, then two, end. And if we change these two, How do I want to do this? I think I do want to do this. I'm going to stick with my earlier observation that we really should not do it that way. So we should do it like this. And it's going to say underscore else clause underscore. But statements is going to suck that all up. I kind of want an expression or statements. If one, then two, end. Editor, if one, then two, three, end. So it's looking for the space and it's not going to find it. I think this is expression or statements, and therefore it could be preceded by that. Editor, if one, then two, end. Ooh, so close. It got to matching this, it just didn't find this because it's not going to. It's looking for a space, but it's not going to find it because expressions will have consumed it. So I think what we're going to do here is that if it's an expression, it should it's always a little bit tricky to get the patterns right here. If we're getting an expression there, we should probably match statements first rather than expression. Really, it's just all an expression, right? What we want to match is we want to match if it's got a new line. It can either be an expression right there, in which case it will not have a new line. I kind of want to do this. Expression or statements is either going to have an expression which is going to start with a space and end with a space. I think that's probably pretty close to right, even though it's a little bit, one, if one, then two, end. So the expression, that's just a single statement ultimately, right? It's that statement though. It is either going to be that okay, and editor, if one, then two, end. Woot, editor, if one, then two, three, end. Woot. Okay, whew, that took a little bit. Now let's go re-enable this. This should be that, and then nothing there, and then the else clause is going to be else that. And we'll deal with that in a moment, I suppose. Don't really probably need to separate the else clause. If one, then two, end. Else. Great. So now we have if. Last but not least, we need to parse while, which should be like easy compared to what we were just doing, because it's just the same pattern. While expression is going to be a while. Do, end. While and 1, 2, 2, 3, end. Doesn't like it. Oh, I know why it doesn't like it. That's an easy one, because it's not here. Ta-da! All right, so now we have memory, we have parentheses, we've got operators, we've got while, we got if, statements, this is matching statements, and now we need to make it actually do something. And here's where it gets interesting. So we need evaluate. Let's start with this. Evaluate. So we're going to break this up a little bit. A value can be a simple value, which is one of those things. I think a store get and a store set is actually just an expression. So let's bring this up here. And this is actually just another kind of expression. So really, a value is a simple value. So we don't need to evaluate. We're going to do that, import, and our standard lib will be fine for right now. So now when I do the REPL, I need to go over here and see how the REPL works, because the REPL, we're saying run the REPL, it runs it with the parser, the parse finishes, parsed, and we have an evaluate. That's what I wanted. And so as long as you put the keyword evaluate in here, it will actually attempt to evaluate it if it's present. So now we do 1. Not really evaluating much, but it would have to come all the way from the top. So we're going to say the root is just a value. I'm just going to end run this a little bit so we can test this. 1. Root is a value, but it is also does not have evaluate. So we're going to put the same thing here. We're going to go ahead and put evaluate up here. Undefined, great. Not really great, but kind of great. First of all, I'm just trying, I don't even remember what my args are there. That's why I do it like this. 1. No arguments. And then self. There we go. So self has a root type value. I think, in this case, let's just say I'm going to go value.evaluate. And now here, we're going to take the value here, and we're going to say eval I believe we just convert to string. It doesn't. It does indeed. All right, so now let's get a little more exciting, doesn't it? So now we're going to say, this is now a statement. We want to kind of go up the ladder. So we're going to say this is just expressions right now. And we're just going to take the expression and evaluate it. Now the expression, we want to now accept the next thing, which is an operator expression. And we want to say evaluate. And what we're going to do is we're going to say, ooh, look at this little magic. Well, I guess value should have two things, but I kind of like left, right. So we're going to say at left evaluate. And we could do a couple different things here, but I'm just going to do it this way. Right now, we're just going to do this. No can-dos fail. What don't you like there? Expression root, right. I know exactly what you don't like there because it's thinking that this is a function, which is trying to implicate what this is an input, but it knows that strings are not functions. Expression.evaluate is not a function because it's not. I'm going to pull this one out. So I think I might need to do a little extra work there. So we're going to say evaluate. Look at that. So we say plus 5 divided by 77, so that should be 70 divided by 7 should be 10, plus 5 should be 15. We've actually not ever really tested that particular combination of things, so we'll just do this right here to make sure it works. But it should, its value, it should expect expressions. And this is where we might need maybe, I don't know. Plus 5 plus 6, 5. Cool beans. Coolish, beanish, Maximus. All right. So we're getting close here. That's getting close to my time, but we almost have what we need. So the last thing we need to do is does the parser let me have sort of like a, I think the parser does have a little section. Constructor has options, parser, source, and that. I think I'm just going to make it super slicey dicey. So what we're going to do is when we evaluate from the root, we're going to say at parser, which gives me access to the parser, dot Turing store equals that. And now we can actually start to look at what store get and store set do. So store get is going to do evaluate. It's going to say at parser, sub Turing store sub expression evaluate or 0, because we're always going to slice it down to, it has to be a whole integer. And then we're going to go up here to the set, store set, get, get, we don't really want to do that. We're going to go ahead and just put the full match in here. E index value. So now I can say Turing store sub index.evaluate equals value.evaluate, and that will assign it to the store. And this is going to reset. I'm going to do it like that, and then maybe we might have a reset command or something, but I want to be able to just interact with this store a little bit more interestingly. Let's try that again. Close my window. cd ambiem cd CaffeineEight cd examples. There we go. Turing caff. All right. We're going to say +1 is that. We're going to say sub0 equals 2. And now I want to say what sub0 is. It is 2. Sub1, sub3, sub100. You tell me. I don't know what's going on. Let's find out. Fetching this. So first of all, I'm going to figure out. I'm going to say we're going to do index. Log returns the last value. So I just want to know what these are without interrupting the flow of things. Sub0. Defined, undefined, store get. That's interesting. I think it's because returning undefined, that's what's triggering that. But I said 0 equals 2. So it's always doing 0. That's what's interesting. Expression.evaluate. Oh, we need to actually execute that. Sub0 equals 2. Sub0, sub1 equals 3, sub1, sub1 plus sub1 plus sub0. Actually, it's not 2 pluses because that's not how it works. Lots of logs going there. I think we got it. You know, I think I might switch this to postfix because I find postfix easier to think in than prefix. You don't like me. Oh yes, that's why, because you cannot have a list as your index to a array reference. Totally reasonable. Oh, that would be brilliant. Think about that. I've been thinking about how to do better errors. So here's just a little side thing. So here we have the problem that we have an index. We've got a comma, which means we got a list inside a array dereference. So what I would like to have it say is, you cannot have a list inside an array dereference. How does it know that? Well, what if I put a matcher which matched that? So it detected and matched it correctly. And then we had a error that got triggered after the fact, like after the validation. Because I've got a validation, so I get parsed, and then we've got a validator afterwards that goes through and validates things. And so that might be a way to do that. And then we have to sort of, that's a little ad hoc, right? Because like every little error that comes up, we have to think, oh, what's a good suggestion of what that error is? But that might be really a good way. I've heard Elm's got really great error messages, and I want to try to do that too. It's one of my goals. All right, so +1, 2. Sub0, and it's going to do that. I need to change that. So the sub0. If I return null, is it different from undefined? Let's see. think it's just going to show it anyways. So the default value is just always going to be 0. Well, we'll just make it -1, right? So we'll make it like a little, it's just like stupid error codes, but we're not trying to deal with null at the moment. So we're going to say sub-0 is going to say -1, which is really a lousy pass value too. But that's right now. Excuse my French. So we got that. I think we're getting close, right? So now we actually are. So we need to do some more stuff. We're getting close, but we're not quite there yet. I got maybe 10 more minutes, and then I got to really skedaddle. I store set value. Operators is just basically a regex, so that doesn't need to have an evaluate. All these things don't need an evaluate. These are like tokens. Operator expressions got to evaluate. These all evaluate. So we don't have is parenthetical expression. That's an easy one. Evaluate is going to be at expression.evaluate. Great. Let's just make sure that works. Because right now it doesn't work. But now it does work. It does work, which is great. With prefix and postfix, we may not actually need parentheses, but we'll leave them in there for the moment. But I might remove them when I do the final demo. So that's good. Let's do an if. So you notice I've got these 2 alternate matches here. It can be with or without the else clause. And what I can do is pretty cool. So I'm going to say, first of all, the condition. Let's just do it. We're going to say if expression.evaluate does not equal 0, because that's sort of what we're testing. We're going to say 0 is false. Then we're going to return expression or statements. Oh, wait, do those. Dot evaluate. Didn't get my parentheses in the right place. Like that. And then else, or either we're going to return, I think we're just going to return 0 for like false. Like we're always return false if we don't have anything else to return. So we're going to say else clause, if it's present, evaluate it, else return 0. And that might just fully do it. So that's pretty cool. Let's try it. Else clause to evaluate. We do need to make else clause know how to evaluate. And that just needs to go with the expression statements that evaluate. All right. If 1, then 2, else, then let's do that. Evaluate is not a function on this set of expressions or statements. Expressions or statements comes up here to expressions or statements, and so we finally need to solve this problem. It can be statements or an expression. Statements is fine. We're going to call that a wrapped expression. And a wrapped expression is now evaluate expression evaluate. And this is, and then statements is a little bit interesting in that it's got more than one statement. So right, what we want to do then is we're going to do this, evaluate each statement in statements, because it's automatically going to be plural. Last equals null. Last equals statement dot evaluate. And we're going to return last. I think that's about the cleanest way to do it in CaffeineScript right now. We could say reduce, ignore the previous value. Now, let's just keep it simple. So we're going to go through and evaluate each of the statement and statements. Great. If 1, then 2, end. Still doesn't quite like me. End is not defined. because I'm running CaffeineScript. Now, I'm running our Turing parser. If 1, then 2, end. And this is, now just needs this. Matches sub0.evaluate. If 1, then 2, end. Great. If 0, then 2, end. Should return. Let's make sure that's always returning 0, if nothing else. But the if should, I'm just going to put it there. Like, no matter what, we're always returning 0. If 0, then 2, end. Evidently not. Else 3, end. It does do the else 3, but why is it not? I mean, that should always return 0 there. We can do it this way. Love it. Love my language. All right. So if 0, then 2, end. And it says if, and it's returning undefined, even still, even though I put the question mark there. I don't think that's how it's supposed to work. If, and then it is returning 0. So if we're doing statements, oh, we're so close. I want to finish this. 1. Zero. Why is 0 not returning? I'm not even doing anything. Fine, we'll just throw it out. So that's a value. Oh, because we're not well, it's not statements at the top, so let's go and fix that. Evaluate and find. And then we've got that over here in our REPL. Actually, I'm going to remove that. Well, yeah, duh. All right, so statement is that. It still says statement value is not a function. Zero. Evaluate. So there's no evaluate, and it is on end line. End line. Well, let's go statement. All right, we say evaluate. That looks good, but now we're going to come back to the question of why are we not returning? Last is 0, so it should I just return 0 all the time? Does it always just show me the tree? If I return non-zero, does it not show me the tree? It does. Let's go over here to REPL. When does it decide parsed? It should not parse. It should be question mark. And really, actually, what I want is we don't seem to care about result. We're going to log, right? I want to say if undefined equals result, then parse else result. Only undefined gets passed out. It's really what I want. So 1, 0, and we're going to turn around and actually do what we want to do here, which is to say don't always return that, don't do our logging. 0, 1, 2, if 0, then 1, and we do have our extra log here still somewhere, take that out. All right, I think we have everything except for the while statement, and you can see that the while statement is going to be super similar to the if expression. Let's just do it real quick, right? So we say while expression.evaluate does not equal 0, expression or statements evaluate, and last equals, right? Because we're going to return the very last one. Last. Let's just make sure it parses. I'm not going to try it. Since we have memory, we can do this. But I'm going to say while 0, then 1, and then that should return a 0, or not parse. Because it's not while then, it's while do. Right. All right. So I think that's actually the whole thing. So that was pretty good. We managed to do that in, what, an hour or so? And that was just the first pass. Now I'm going to go through and I get to explain it simpler and without a lot of these end runs that I just want to do. So look tuned. Look forward to that. I'm looking forward to that. Stay tuned. All right. Thanks. Bye.